In this video, we are going to discuss about planning in artificial intelligence. What is planning? Before we are trying to reach the goal, we have a plan. We have a set of actions to be performed. It's nothing but planning. So here planning is nothing but find a sequence of actions that achieve a given goal. Okay, so before you are trying to reach the goal, you can have an idea of what are the steps to be executed, what are the action to be taken place. Okay, here a set of operator descriptions, initial state descriptions, and goal state descriptions. All descriptions with that we have a complete plan. Okay, then the plan is going to be computed to reach the destination, to reach the goal. So planning versus problem solving. Okay, the planning and problem solving methods can often solve some sort of problems, some issues. Okay, planning is more powerful than this problem solving technique. The states, goals, and the actions are decomposed into set of sentences. Then that includes plan space and state space. Then planning problems. The actions are given as a logical description of the preconditions and the effects or actions. This enables the planner to make direct connections between the state and actions. So the planner is free to add actions to the plan wherever they are required. Okay, the most part of the world are independent of the most other parts. We can go for using this divide and conquer method. Example, get a tea, biscuits and a book. This is the task. How do you plan for this one? Initial state, the agent or the human being is not having tea, biscuits and book. He is at home. Then goal state, the person or the agent is at home with tea, biscuits and book. So how do you reach the goal state from the initial state? You can have a plan. Initial state, at home he is having no tea, biscuits and book. It's a negation of tea, negation of biscuits, negation of this book. And goal state, there exists at home of S. The current state, the person is at home with tea, he is having biscuits and having the book. So how do we reach this goal from this initial state? Okay, we can have some operators like for all. Have tea. How do we get tea? You can go to the tea shop and buy a tea. So these two actions should be performed for having a tea. So he has to go to the tea shop, then buy tea, and he has to get the biscuits also. Then he has to get book. So execute the steps one by one to reach the goal. Simple planning agent. The perception to build model of the current world status. We can make use of this functions like ideal planner, state descriptions, make goal query. For example, the ideal planner given a goal algorithm generates plan of actions. State descriptions given perception. It returns the initial state descriptions in format required by the planner. Make goal query used to ask knowledge base what next goal should be. So you have any plan about the initial state and goal state using this actions, using these functions, we can have this state descriptions plan of actions. So we have different planning languages like Stripes, ADL and PDL. Okay, the Stripes stand for Research Institute Problem Solver. It's an action language which was a part of first major planning system with the same name. Then ADL, Action Description Language, is the extension of Stripes. And Planning Domain Definition Language, here an attempt to standardize planning languages like Stripes, ADL. These are the available languages for planning. Example, here planning in AI, we can go for using solving some problems. Here example, take block swirl problem. In this block swirl problem, here it consists of a flat surface tabletop. This is the table. Then in this table we have this blocks like A, B, C, D. So we have set of identical blocks with which are identified by letters like A, B, C, D. The blocks can be stacked one on one to form towers. So this can be placed like top of A is D, top of D is C. Like that we can make a tower. It's unlimited height. Then here we have a robot arm with empty hand for picking these blocks, for arranging these blocks. Then the condition is the robot can hold one block at a time and only one block can be moved at a time. With this scenario, we'll see how do we solve this block solve problem. Here we have 4 actions and 5 predicates. What are the 4 actions you can perform to solve this block solve problem? We have unstack, stack, pick up, put down. What is unstack of A comma B? That means pick up clear block A. What do you mean clear block? Clear block in the sense on top of A we have no other block. This is the top of the block in the tower. Only the robot arm can pick the top or which is on the table top. Okay, so clear in the sense the top of the particular block, no other block is placed. So here pick up unstack of A comma B means this A is kept on top of B. Now pick up this A from B and stack it. Stack of A comma B in the sense place block A on top of A, to the top of B, which is clear. Initially the block B is a clear block. Now after placing this A on top of B, now A is a clear block. Pick up A. What is pick up A? The A is placed on the top of the table. Then lift the clear block A from table with empty arm. Put down means put that A on top of table, not other block. So first to unstack and stack means the particular block is placed on the other block. Then pick up and put down for picking a or putting a block on top of the table, not to any other block. These are the 4 actions we are performing in this block solve problem and 5 predicates like on A comma B, on table, clear, holding, hand empty. On A comma B, block A is on block B. That is A is kept on top of B. On table of A in the sense the A is on the table, not on any other block. Clear A in the sense block A has nothing on it. Holding in the sense the arm holds the block A. Hand empty means now robot arm is empty, so we can utilize it for picking any other block. Then planning systems. Initial states are goal state, set of rules. Here this is initial state we have. This is a goal state. How do you reach this goal state from initial state? So how do you describe? Initial description about this blocks world on top, on table A. Yes, A is kept on the top of table. On table of B, yes, B is on the top of the table. On D comma A, yes, D is kept on top of A. On C comma D, yes, the C is kept on top of D. Then clear B, no block is placed on this B and no block is placed on the C, so it's clear C and clear B, hand is empty. This is about initial description. What about goal state? What do you want to reach? Here on top, on table of BS, top of the table we have B and C, and D comma B in the sense D is placed on top of B and this A is placed on top of D. Hand is empty. So how do you reach from this initial state into that goal state? So what about the operators we have? Pick up, put down, stack and stack. In that each actions we have preconditions, delete list, add list. The same preconditions. You want to perform the particular action we have some preconditions. If it satisfies, we can perform the particular action. Then from current scenario, delete some statements, add some statements. This is delete list and add list. So you want to perform pickup of X, then you have to check whether the particular block is clear on table, hand is empty, you can go for using this pickup. For put down, they should have that arm should have the block X. Stack of X comma Y preconditions holding X, and you have to place this X on top of Y, and the Y should be the clear block. And stack of X comma Y in the sense clear, the block which you're going to pick is clear block, and that should be on the top of Y. So if you perform pickup, you have to delete these two and add these two statements. Like that we have for put down, stack and stack. Now how do you reach from this state to into this state? This is the final state or goal state. So we have a set of plan like unstack of C comma D, then put down of C, unstack of D comma A, D comma B, A comma D. If you perform, you have a plan for performing. If you perform, if you apply this plan, you'll get this execution, the plan execution, then you'll reach this final state. Then next topic is about means and analysis. Here the means and analysis solve the major parts of problem. First, then it's going to solve smaller problems. Okay, so in the entire problem, it just concept macro and micro levels. Macro level will be completed first, then complete your micro level problems. The algorithm of mean and analysis. First, measure the current state of the things by doing the study. What about your current state in the micro and macro level with that goal state? Then keep on your moving that, find the difference, and yeah, solving that macro level, then possible micro level. Compare current state and goal state. Keep on doing this one, and you are going to proceed this one till you are reaching the final goal. So here, initial state, whatever you want to perform, you can consider this micro macro level. You won't delete anything, you want to move or you want to expand. The thing is, you are going to achieve the goal state. So like that, you have a very big goal can be divided into sub goals. Again, this can be solved by performing some actions. Then machine learning topics. Machine learning, the learning is nothing but it improves its performance on future tasks after making observations. That is, we are making machine to understand, and it's got to take some necessary action, or it has to take some decision like human being. So here it needs some component to be improved, prior knowledge, then feedback is also required. So here machine learning, the Mitchell has given a definition like a computer program is said to learn from experience E and respect to some class of task T and performance measure P if its performance at task in T as measured by P. The other definition is it's a subfield of computer science, but it's often also referred as predictive analysis or predictive modeling. The main thing is we are going to use machine learning for predicting. The goal of ML is to understand the nature of learning like human being. So to make the computer smarter, more intelligent, develop the computational models of human learning process and perform computer simulations, and to explore new learning methods and develop general learning algorithms independent of the applications. So what about the dimensions we can say? The speed when compared to human learning and machine learning, the speed is both are slow. Ability to transfer, we cannot do copy in this human learning. We can do it in machine learning. Required repetition is possible in both cases. Error can be cleared and noise tolerant is not in this machine learning. So there are four types basics. the supervised learning, unsupervised learning, semi-supervised learning, and reinforcement learning. We'll see one by one. The supervised learning, we have some label data with some known facts we are trying to find. For example, if shape of the object is given round and it's in red color, then you can say this will be this are the classes available. If you are giving the information like this, then you can decide this may be apple. So this can be divided into classification regression techniques and semi-supervised learning in the sense the combination of unsupervised learning and supervised learning. You can also say it's a weak learning method. Okay, some are having the label data, some are not having the label data. So the combination of these two will be the semi-supervised learning. Reinforcement learning, in this case, will take feedback from the environment. For example, if any game is there, then you can go for adding some reward points in this kind of learning. And in sample learning, here we have more number of models that are going to be combined and trained. Then from this more models, which is going to give you the better solution will be used. The different techniques are bagging, boosting, stacking, or the techniques used in sample learning. For example, we have more number of models. Give the input sample, get the output, then find just having the best solution. Vote for it and make use of the solution. Okay, this is about ensample learning. Then the expert systems. Expert system is a computer system that emulates or acts in all aspects with decision making capabilities of human expert. This is given by Edward. See, sometimes we need some experts to train the model or for using these systems. So here, the architecture of this expert system it's having this knowledge base, inference engine, user interfaces. Here, user interface giving the inference engine is going to analyze. It may be from this knowledge base and working storage, and also everything is done by the machine. Along with that, domain expert, they are giving some knowledge. Okay, the previous cases only we are believing on the machine. Here, with the intervention of this human, we are going to proceed with the systems. Here, inference engine, explanation facility, knowledge base acquisition facility, and experts user interface user. Here, knowledge base it stores all relevant informations, data, rules, the relationship used by the expert system. Okay, then inference engine here that seeks information relationship from the knowledge base and provides answers or predictions or suggestion to that human they're asking. Then explanation facility it allows the user to understand how the expert system arrived in certain conclusions or results. Okay. Then knowledge acquisition facility that provides convenient and efficient means of capturing and storing all the components knowledge base and it acts as an interface between the expert and the knowledge base. The user interface it is designed for using that particular system. The main purpose of this user interface is to make the development and use of the expert system earlier for users. Only through this user interface, the user can make use of the system. So with the intervention of users, experts, we are going to use this one. Thank you.